Okay, well, thanks to Rolf for organizing this. I think this is great to get together. So what I'm going to be talking about is trying to address in a small way, I think, Rolf's first bullet point about theory and what theory do we have to underlying integrated models. And this is something that I've been kind of thinking about for some time, and the origins of some of what the origins of this talk actually go back, over a dozen years to the early 2000s. Part of it started when Martin Lee Gosselin and I had a fairly big project on behavioral processes and activity travel models, and Martin convened a very small little workshop, something like this, but even teeny tinier at Imperial College with some of our European collaborators. Kai Axhausen was there, John Pollack, Sean Doherty, who was working with us at the time. And we were talking about the activity models we want to build, and it got me thinking about, well, I don't really understand. Martin was a data guy. He said, we're going to collect data, we're going to do a panel survey. What data do you need to build your models? And that begged the question, well, what does the model look like, and what sort of model do we want to build? So I started thinking about, if I were to build an activity-based model, what would it look like? And part of that thinking led to the Tasha model, which I mentioned earlier is actually operational now. I think the other half or motivation of this was about a year later at IATBR in 2003 in Lucerne. Harry Timmermans gave a keynote talk on land use modeling, and he complained about the lack of theory in the models and complained that we just see the same old logit models and the same old log sum terms showing up over and over and over and over and over again. A bit of an exaggeration, but and so that got me thinking about integration, particularly between transportation, travel, which is a short run, day-to-day kind of activity, obviously evolves over time, and the longer run decisions of where we live, where we work, and so on. And so again, I've been noodling this notion of what is short run, what is long run, how does it intersect? So I think it's relevant to this conversation, because we are dealing with transportation and land use, but I'm stepping back. There's nothing very practical in this. This is a very theoretical kind of conceptual discussion. Certainly, I don't have a lot of solutions. But the thing that I've sort of set myself to try to do is to, can we have a comprehensive framework as the underlying basis? I don't like to use the word theory because that sounds a little grandiose, but at least a framework, a conceptual framework that deals with both people and households and perhaps eventually firms, that does allow us to integrate temporally between the short run and the long run. I would like the framework to be behaviorally sound, so it's not just ad hoc, but it is operationally implementable, and those two things don't always go together well, particularly if we want to be computationally efficient, and also want to be very general, very abstract, so it's extensible. So if we get better data, get better theory, it can accommodate it. We don't have to throw everything away and start from scratch. So really what I'm going to talk about today, and again, I'm mindful of Rolf's instructions not to fill the 45 minutes with me just talking. I just want to throw out a few concepts, a few ideas that underline the thinking, and some terms that maybe I'm using a slightly different way than other people do. But to me, these are some of the building blocks of the framework I'm trying to build. So the notion of resources, and I think perhaps this is the most, the biggest part of this talk, and maybe the part where I'm trying to change the conversation a bit about how we think about land use and transportation. What is it that we're modeling? And I'm going to make the argument that what we're really modeling is resource usage and resource acquisition. The notion of projects, which some of you have heard me talk a lot about in the past, and then also the notion of stress, which I think is a key concept into maybe how we do bring short run and long run together. For me, the big question was, I started with, well, what do if we're going to build a behavioral model of people's activities, well, what is it that they do? What do people actually do? And I would argue that they perceive and respond to their environment around them, and they act into the world and thereby change it. And I would argue one way of thinking about what people do in a very, very generic, abstract sense, is that they're making decisions and then acting on those decisions regard to the acquisition, allocation, usage of household and person resources. And what are those resources? Well, first of all, it's time. We have to spend our time. It's money. Money enables us to do things. It's also goods and services. I'm going to be focusing on particularly housing and cars as major tangible goods that we're concerned with. But we've been having conversations with Darren about in-house, in-home activities. So resources like washing machines and televisions and so forth. These are all goods that are available to us that we have to acquire and then we use. And something I'm not going to talk at all about today, but also knowledge is a major resource that we acquire and use over time. And at a key point of this I'll elaborate on is that at the difference between the short run and the long run for me is in the short run, our resources are fixed. We have a fixed income, we have 2 cars, we have this house, we work there, and so forth. So we are making our day-to-day decisions in using the available resources, which both enable but also constrain what we can do. And for me, the long run is our decisions to change those resources over time. But understanding those resources, Ralph talked about constraints. In the short run, this is where the constraints come from. We only have 1 car, we only have so much income, we only have so much time. So if we think about, take an activity-based approach to this, we think about anything we do, any given activity episode, one event in our life when we do something, every activity episode requires resources. So the inputs are, first of all, again, time. We may well have to spend some money. We may use some technology. We may watch the television. We drive the car. And we have to have some knowledge. We have to understand how to use the car. We have to understand where we're going shopping. So there's knowledge that we're using, and we engage in the activity, and we get resource outputs from that. We hopefully get some utility out of that activity. We may get some money. We may get paid for our activities. We may purchase some durable goods, some technology, and we may gain some knowledge. So we can think about everything we're doing is these flows and fluxes of resources in and out, the usage and the acquisition of it. This is kind of tangential to the main thrust, but I'm getting more and more interested. I teach a course in complex systems theory and cities, and we actually start with system dynamics, which is all about flows and stocks. And I think it's kind of interesting to again think about these resources. What are flows? What are stocks? And time, I think, is very interesting because time is a pure flow variable. One of the absolute characteristics of our lives is that we cannot store time. And I would actually argue that money is one way we store time. We work, we get money. That money then allows us to hire somebody to mow the lawn, save us time later on, or and so forth. So one way I think we save time is through money. But in any event, time is a flow variable. I would argue that money is a flow variable the way we use it. Money, we have money exchanging all the time. But the stock is our equity, capital savings, and so on. We can save money and have stocks of money. Utility, I think, is a flow variable that we don't usually, I don't think we really think about the sort of the time value of utility or the temporal aspect of utility, but I would argue that utility is something in a sense we consume, we experience in the moment, and get that benefit. Possibly, and this is, again, I don't know that people are thinking about this, but we hear a lot about well-being, happiness, satisfaction, which people do try to differentiate from utility. There is this notion, and which is maybe there's this notion the economists have narrowly defined this notion of utility, and then there's something called happiness or well-being. Arguably, maybe well-being or happiness is the accumulation. It's the stock variable. If we have a lot of experiences that give us good utility, maybe that makes us happy and satisfied with our life, whereas if we have a lot of bad experiences, then, disutility, then maybe we don't have so much well-being. Anyway, that's a thought. Information, I think, is a flow variable. Knowledge and memory is the accumulation. And then we have durable goods, which clearly are stocks, but then we have the time usage of those goods. Anyways, that's, as I say, that's a bit of an aside. So if we're talking about resources, I would argue that a lot of our decision-making has to do, again, with constraints with the budgets we have. We have budgets on all our resources, and we have to manage those resources. And so we are constantly constrained by, we only have 24 hours a day to spend on, we only have so much money, and so forth. So what we're faced with as we move through life is the need to, we have to spend our time, we have to allocate our money. There's only one car in the house. If there's only one car, each car can only be used at one point in time by different household members, so there's an allocation of that resource. So we have these budgets that constrain what we can do, particularly time and money, but also the physical availability of our physical resources. I think in the longer run, in the bigger decisions, it tends to be monetary budgets that constrain things. Where we live is constrained by where we can afford. In the short run, in terms of activity and travel in particular, it's usually the time budget that's the major constraint, but there could also be a monetary budget, and both are really operative at any one time period. So understanding those constraints and understanding that budget management, I think, is central to what we're trying to model. Time, again, is a very particular variable that we're dealing with. From a modeling point of view, time is obviously continuous and forward-moving, but from a modeling point of view, we're always, just as we do with space and everything else, we have an aggregation issue in terms of how we're going to handle it. We divide the day up into time periods. We model a single typical day or a week or whatever, depending on what we're doing. But in particular, as I've already kind of said, I think for this talk, I think the two key divisions that we have in our models and our thinking is we do think about there are short-run decisions and there's long-run decisions. And I would argue in an integrated transportation land use model, that's exactly what we're trying to deal with. We have transportation, travel, which inevitably we're modeling as a typical day in practical terms. One can think of other options, but these are short-run decisions about what we're going to do today. And then the land use is about where do people live and where do they work. Where are we going to build? And these are the longer run decisions. And again, within this resource framework, I would argue that my definition of short and long run is the classic microeconomic one. A short run decision is something that's going on with fixed resources, whereas the long run decision is about changing those resources over the long run. But we always act, when we talk about long run decisions, we can only act in the now. So we can remember the past, we can think about and plan for the future, but we can only do things now. And so when we're modeling, even if it's a static equilibrium model 20 years in the future, we're modeling, the outcome of some decisions that will lead to that activity. And so in this framework, what I'm trying to work towards is these long-run decisions about, do I move my house, do I buy another car, do I change my job, do I go back to school and get more education, which is another kind of resource, that these are classed as long run because they affect the long run constraints on us, the long run resources, but they happen at some point in time. There's a day when you wake up and you decide you're going to move or change jobs. And so I think in terms of modeling these activities, a key part of the major challenge is modeling the when, modeling the triggers. When does somebody decide to move? What households get active in the market? Who's active in the job market at any point in time? Because we're never active in these markets all the time, but we are some of the time. So understanding what triggers these long-run decisions, I think, is central to building an integrated model, and I think that's one of the challenging parts. It's made more complicated by the fact that we have multiple planning horizons over which we're making these decisions. You're at work in the morning, you're trying to decide where you want to eat lunch that day, but you may also be thinking about what you want to do for vacation next year, and if you're my age, you're thinking about, well, when am I going to retire, and what am I going to do after that? So there's, planning it goes on over multiple time frames as well, and the question is to what extent do we have to handle that? So if we think about time and modeling processes in time, there's lots of lots of modeling issues I think we're all familiar with. But I think the key one is, and time-driven versus event-driven representations of this in the model, which I think is extremely important, and I'd love to have a conversation about that. But to me, some of the major decisions are, how do we model triggering long-run decisions? How does the past, how does our experiences affect our current either day-to-day or longer-run decisions? And that, I think that is maybe the central question, is how does the day-to-day affect the long run? And to me, that's where the linkage, that's the critical linkage between transportation and land use. Is the transportation is that short run day-to-day, the land use, quote unquote, is again these longer run decisions. How does that, what is that connection? And again, maybe just bringing a log sum accessibility term up is maybe not the best way to represent that. Second concept is projects. This is, Kai, among others, has been talked about projects a long time. I think this is a really nice way of organizing, representing the range of activities that we engage in. In the Tasha model, all activities generate out of a set of projects. I don't think I want to spend time talking about projects here, but in other papers and other places we've argued that one way that we actually organize all human activity is within everybody has a set of projects. They may come and go. You have a work project, you have a school project, etc. But that at a minimum, it's a very convenient way from a programming point of view to organize a practical model. You can encapsulate different behaviors in the different projects. But I think it also, it has the potential, again, to providing, in a sense, a universal model. Arguably, everybody has the same set of potential projects. How they get realized in different societies depends on technology, culture, and so forth. But it might be a step towards having, a common model if we were all working within, in a sense, the same set of projects. And I do think there are advantages of the project approach in terms of encapsulating behavior to handle the complexity of human behavior and all the things we do. This is a way of compartmentalizing the model, if you will, but I think we also do it in our lives. So the idea is the work project knows everything about about work, the recreation project knows about recreation. The two projects don't have to know anything about the other. So while you're making decisions about work, you're not simultaneously thinking about whether I'm going to go golfing on Saturday. So you have individual projects generating activity, the need for engaging activities and the knowledge and so forth associated with that. As I say, again, that's a very practical approach from a programming and modeling point of view, but I think it's close to what we maybe do. We do compartmentalize. The example I always use is on a given day, my wife doesn't know what I'm doing particularly. She knows I'm at work, but she has no idea what I'm doing at work. She doesn't need to know that to have her day. Similarly, I'm not sure what she's doing that day. And it's only when we intersect and have to share resources, like I need the car for the day, that we have to necessarily exchange that information. So I think these sorts of things go on all the time. But with that structure, then we need to say, okay, the work project wants to do certain things, the recreation project wants to do certain things, the home maintenance project wants to do certain things. Maybe they all want to do those same things at the same time or the same day. So how do we reconcile that? And the argument I would make is that it's another entity or object, if you will, in the model is a resource manager, which is, in order to engage in these activities, we need resources. So we need time, we need money, and it's the resource manager that takes the competing activities, the competing projects, and sorts out what's actually going to be done. So it's the resource manager who has the more global view of, well, I could spend Saturday afternoon mowing the lawn, or I could spend Saturday afternoon going golfing. Those are two competing ideas generated by two different projects. It's the resource manager that decides how to allocate the actual time to an actual project. So it's at that level of decision making that we bring these competing things together, decide how we actually will spend our time, money, or resources such as cars. So the project manager, in a modeling sense, would check for the feasibility of different activities and sorts out what can and can't be done, and possibly modifying things. So practical examples of resource managers would be things like a money budget manager within your model, saying, how are you going to allocate money to different activities or different goods? How much money can I, Rolf was talking about household expenditures. So this is the idea that households have to allocate their budgets across different kinds of housing, transportation, clothes, food, and so on. So how do households manage that allocation? And we see, in the data, the outcomes of what they do at that level. Our travel activity scheduler models are, I would say, time resource managers. In Tasha is an example of a activity scheduler. It actually schedules activity episodes over the day. It allocates time to schedules. In this framework, that's a time manager. It's a time that's taking, in this case, literally suggestions from different projects in terms of what to do, and it decides what you're actually going to do. So it's managing time. Similarly, in Tasha, we have an auto usage manager. Each person makes individual decisions about what they would like to use the household cars for, and the household then looks at that, the car usage manager looks at that, and if there's competing demands for the car, sorts out who gets the car and not. So there are some examples of this in application. Similarly, we don't spend time on this, but again, examples of actually keeping track of what you're spending money on, and I think what's important, potentially, is differentiating between the monthly operating budget and the long-run capital budget. So we have to balance the books, let's say, on a monthly basis, but then we also have a capital budget over time of savings and debt and so forth. And I don't think we really have models that deal with both of those things, but I think implicitly, these are the things we're dealing with. I mean, particularly something like housing. We talk about housing prices, but what's really important is, can I make the monthly payments on the mortgage and the operating costs on the house? That's the actual decision people are making in terms of how much they can afford to pay for the house as a whole. So I think thinking about money flows, and certainly in transportation, we spend almost all our time dealing with time budgeting. We don't spend a lot of time dealing with money budgeting, but certainly in these longer run decisions, that money budgeting, I think, is very important. The final So putting these ideas together is, how do we actually go about changing resources? So we actually need resource change projects. So part of, let's say, if we have a shelter project, which is dealing with everything to deal with our housing, that project would have to have the capability. This is where the triggering decision would occur, saying, I've been monitoring things, and I think it's time we move. And in principle, that would launch another type of activity, which is the search process, the actual getting involved in the activity in the housing market, and engaging in search and deciding to actually move. Similarly with the car, car ownership, the mobility project should be monitoring the situation. Say, you know what, I think it's time that we trade our old car in and buy a new car, or it's time we get a second car. So this is where the triggering mechanisms would lie, is within these projects. We have, as in our ILUT model, we have sort of vestiges of that. We don't really have a project formulation in the current ILUT structure, but we do have mobility or triggering models. Each year, each household decides, do they want to enter the housing market or not. Each year, the household decides whether to buy or sell or trade a car. So these are kind of prototypes or vestiges of this sort of notion of constantly monitoring your status and deciding when is it that you want to change. So we actually have in ILUT, and I don't have time again to talk about this, but we model markets, because another aspect, I think, of almost all the long-term decisions we're talking about, cars, jobs, houses, particularly, these are all actually go on within a market process. So understanding where somebody moves, somebody can't just decide to move someplace. They have to engage in a market process and be successful in renting or buying a house in a certain location in competition with other agents. And so if we want to understand residential mobility, labor mobility, and so forth, we really have to be modeling it within a market process. Again, I think one can establish templates for how markets work. And certainly in ILUT, we're micro-simulating simulating the housing market, house by house, household by household. I think the final concept that I want to briefly talk about is one of stress, and this is certainly not a new concept at all. It goes back in housing, it goes back at least to Rossi's seminal work in the 50s. But I think, and this is really where we're starting to get to the connection, particularly between the short run and the long run. The argument is that stress is some sort of difference between one's current state, which could be your current activity pattern and the current situation you're in, versus what you might have some expectation or desired state. So this relates to prospect theory and reference points and so forth. And the idea, very simply, is that if that stress exceeds some threshold, then you may become active in the market. So this may trigger your decision to change things. So what was I going to say? Lost my train of thought. So this again potentially. So this is potentially a potential linkage between the short and the long run, because as we live day to day, our current state is changing in various ways. Maybe our expectations is changing. If you're looking at the housing market, maybe the housing market's changing. So maybe this is a good time to buy, and if that relates to how that relates to your current state. If you're very, very, very happy where you are, you won't move even if it's a good time to buy. But in any event, these two things are changing, and this may be how one model's triggering. Also, I know what I was going to say. What this allows you for is sort of bifurcation. One could say stay in one state for an arbitrary period of time, and then sort of a sudden, discrete transition at some point in time to another state. So you're maybe passive in the housing market, and then at some point this trigger kicks in, and you switch to an active state. Sort of catastrophe type behavior, which is what we see all the time in virtually every market. We've been playing with this stuff for a long time. I don't think we've implemented stress nearly well enough or extensive enough, but we do have some very preliminary examples. We have a stress-based auto ownership model, a transaction model that's actually taking stress signals from the TASHA travel activity model, with the model be saying, gee, we really could use another car, or gee, we don't need a car, and that actually, those stresses actually feed back into the transaction model. Similarly, we have residential mobility models that are looking at stresses to trigger the decision to join in the market. So if we look at what we're currently doing in our model, it's very, very rudimentary. These are some of the big decisions that are being made in the model, and there's a couple of places where stresses are, in fact, trying to inform, but I think it's very, very early days. Much, much more we can be doing there. So again, to summarize, I think the key research questions is, which I certainly haven't answered with this, but just trying to create a framework, if you will, within which we can maybe think about this in a different way and address it, is how does the day-to-day trigger long-run decisions? I think there's extremely practical problems dealing with the short and long run. I think we've already touched on some of these things in the morning's discussion. Just computational efforts. If it's just a model, one day, maybe in 1 year of travel, how does that affect decisions over years and years with respect to residential location? I don't think we want to be in a position where we are simulating every day of the year for 30 years in order to accumulate the stresses and the experiences that trigger something. So I think there's a lot of very practical problems with this. I think within the stress concept, I think there's also a problem of that there are many stresses coming from many locations. Maybe our commuting distances are a little long, our car is old, our neighborhood is declining. How do we handle sort of multi-channel stresses coming in that might be resolved in multiple ways? I mean, maybe we move, maybe we buy a new car, maybe we change jobs, maybe we do all of those. How do we handle those? I mean, I was interested to see Rolf talking about that, many of the events in his model are randomly occurring, and I think getting to that more event-based thing is a good approach. But I think if if we want to be implementing this, we have to be dealing with, as I say, sort of, a multi-channel information flow about stresses, but also a very multi-way of responding to things without having to exhaustively enumerate every possible permutation and combination of responses every time we get it. So I think there's a lot we need to be doing to thinking about that. So in any event, there's a lot of kind of semi-random thoughts there that may or may not be useful to this conversation, but that's kind of where I'm at with some of my thinking. So with that, I'll quit, and we still have a few minutes at least for some questions.
Thank you very much, Eric, for this really useful classification and ordering of things. And when David and Ying and I wrote our article, Equilibrium versus Dynamics, we followed exactly your, let's say, ordering of behavior decisions between short run and long run, where travel decisions, where to go, when to go, trip generation, destination choice, mode choice, route choice, where those which we thought occurred immediately and therefore are justified as equilibria and should be repeated in very, very short intervals, whereas, for instance, demographic processes, family foundation, moves in the housing market, moves in the job market, etc. They are intermediate speed responses, and of course, investor decisions about building residential or industrial buildings have a much longer time scale, and the longest time scale is related to infrastructure. We travel on Roman roads even today, and in our modeling experience, we simply deal with this with delays, following John Forrester, of 1 year, 2 years, etc. So if an investor decides to build houses in a certain zone, they enter the market only 2 years from that decision, etc. So thank you very much. It was very comforting to listen to you.
Okay, well, thank you. And as usual, Michael, I agree with what you say, because I do think, I think, very short run things, I'm very happy equilibrating them. Longer run, I think we need these lags and live with the fact that we're in disequilibrium. Yeah.
I share this the same comforting feeling. So actually, I've made a lot of notes about actually how things actually are structured in this type of very complex model. One question I'd like to ask is to do with the households' sentiments about housing and the housing location and so on. I don't really have an answer. Usually I deal with very aggregate models, so I skate across this by saying, well, in the longer term, the housing sentiments actually could be modeled using equilibrium models, which I know there are multiple pitfalls about that. What I'd like to ask you, and in these more microscopic models and about short-run decisions, is how to treat the sentiments in the housing market, and particularly households' decisions about where to locate, what houses to buy, and also the resulting dynamics in prices, both in the rental market, also in the housing sales market.
Sure of the question, by sentiments you mean like tastes and preferences, attitudes?
It's more to do with the price fluctuations and because the attitudes themselves are important as well, but it's more important that in the short term the households actually don't deal with the kind of long-term markets that I model. Because if you're modeling from year to year, then those sentiments can be important, because potentially you can capture the effects of the boom bust of the markets, and So that's something both I think is an opportunity for the microscopic models actually modeling detailed periods, and also somewhat of a challenge. So how to structure this, I don't really have an answer, but I think the person to ask is you about it, because this is related to what you'd be saying about the rest.
Very good questions, and I don't think we do it well at the moment. I mean, I mean, in our housing market model, it is a totally microsimulation model. So each household in each year basically decides whether to become active in the market or not. That if it's an owner, if that puts that dwelling unit into play, we assume it goes on the market. And then, of course, you also have some new housing. So at any point in time, you can think of a matrix of a set of households that are active in the market and a set of dwelling units that are active in the market. And then we randomly select a dwelling unit and auction it off. So I like to claim loosely that this is kind of a disaggregate version of Martinez's bid choice framework. And so each household will have through a process, which I think at the moment, frankly, is a bit dodgy, will have a set of dwelling units it's considering, and then a given dwelling unit will have a certain number of bidders. We, as I say, sort of based on Martinez's theory, what we currently assume is that there's an asking price for each house, and each household then on this bid says, what's my maximum willingness to pay for this house, so it leaves me no worse off than what I think my next best house would be, given what I think I would pay for that. And then we sell it to the second highest bidder plus $1. So it's a Vickery auction. It works, but I think but the utility function that's driving all that. That's why I was asking about tastes and preferences. Has to do, well, how much do I value this house in this neighborhood versus that, and where I think this model is still very static is that utility function has been estimated in a very traditional way from a logit model. And I actually have very big concerns that we might be locking in, we certainly in Toronto, we see an awful lot of people living in suburban housing. And so I think inevitably, depending on when you're doing the model, you may be locking in a certain worldview about what's valued and what's not. And of course, I think those values change. I mean, we see younger generations moving into the downtown, and so I don't think we're capturing the learning, the adaptation, the evolution of tastes and preferences that I think we need to. My argument is, at least the agent-based microsimulation gives you a framework you can start asking those questions, but then we're a long way from actually doing the research to figure out how tastes and preferences have changed over time. But certainly in terms of boom and bust, within this bidding, you do get, if you have too many people, you can easily have too many people chasing too few houses, and that will bid prices up. We don't tend to see it the other way too much, but you could have too much supply, which would cause prices to go down. So I mean, we've done a lot of 20-year historical runs. We have a 1986 synthetic population, and we simulate it over 20 years, and we can compare the prices coming out of the model to the aggregate prices in the market, and that's a fairly dynamic period. We get some of the highs and lows, and a couple of things we don't catch quite so well.
I think, don't we have a problem because we ignore the labor market? We just take the wages as given. Doesn't that become a problem, in particular in dynamics locations like Toronto, where you had upswings and downswings, where things might change over time? If I look at Hamilton at the south end of your study area, which has seen dramatic decreases in their wages through the decline of the steel industry. So how do we cope with the labor market and therefore the wage question in those long-run models?
That's a great question. And we have basically been doing the same. I mean, and so I guess in some respects there's probably something wrong with our model, that we're doing reasonably well in the housing market and we're taking sort of the employment side as kind of static. I've had one master's student trying to take sort of our market template and apply it to labor. I mean, I think the answer is we have to be simulating the labor market, and which is a much tougher thing.
Isn't the wage level, which means the the welfare of the whole region a matter that is being decided at a higher level in the competition between regions?
I think you could argue that, but on the other hand, even within the regions, you have areas which are improving and declining. And clearly it makes a difference that Hamilton lost a substantial share of its industrial base, as I understand it, and that changed the complete attractiveness of that location. That might have made new industries move in, which hadn't been there before. So I think it's odd that we spend all this time on the housing market and then often not really modeling the household decision, but just the head of household decision, and then ignoring the labor market size.
This is where some of our efforts we're hoping to go into is take that side much more seriously. Because even, Michael, if it is sort of a more exogenous thing, you still need to be knowing what the wages and salaries are in your area, so you know how much income people have. I mean, we sort of have two markets. We talk about where prices are endogenously determined, like the housing market, and then we also have what we call price taker markets, where the price is set, but you still have the longer run question of that price is still being set somehow over time. And in our own discussions, we've never been quite sure whether the labor market, when we finally model it, will be a price taker or an exogenous one in terms of the wages. But I think actually this is a very critical question. Alistair.
On the multiple planning horizons, different timescales, is one of the feedbacks from the transport to the long-term land use pattern the reliability of the transport network? How is that factored in? So, over a long period of time, if your transport network is consistently unreliable, does that change your choice of housing location? In a short time period, in one day, your travel time might be X, but if that varies a lot, is that therefore a reason for someone to move house? And I'm thinking from my perspective, trying to model flooding impacts and things on transport networks, if in the future those networks become more unreliable, could we see effects on where people choose to?
And again, I think this is in travel demand modeling, I think this is a huge issue. So the short answer is reliability, I don't think is in any operational model at any scale anywhere. At UOT, we're more and more looking at the issue of transit reliability. First of all, just trying to quantify it and understand it and even control it from an operational level. But yeah, I think there's probably all our travel demand models, mode choice models, route choice models, I suspect are currently biased, confounded in various ways because we're not modeling the reliability of the transit system. So our alternative specific constants, et cetera, I think there's a problem there. So I think that is a very serious research question. First of all, just to get the travel models better. It comes into bus versus rail. Everybody thinks rail is better. Part of it's because it's reliable, supposedly, relative to buses. I think until we get to that, but again, from a modeling point of view, that's challenging because how do you simulate or model on reliability and particularly forecasting? What do you assume when you build your new system it's going to be perfectly reliable, or how will reliability change in the future? So I think these are some of the reasons we don't model it over and above the data problem. And I think it's not an area I've done a lot of work in, but when geeks like us come to the problem, we said, oh well, we have a standard deviation on bus arrival time, so that's our measure. But that may not have anything to do with how people perceive reliability, right? So I think even just measuring reliability from a behavioral point of view, I think is challenging.
Thank you very much, Eric, and time for us to move on, but it was very good input here. Thank you very much.